So the photoelectric effect is when the light falls on the metal that will remove electron out and the electron move from one plate to another. We call that as photoelectric effect. And the voltage which stop these electrons from moving, that is known as the stopping voltage. And stopping voltage is when kinetic energy is equals to electrical energy and the charges electrons are not able to move. So there are following features which we obtain from this photoelectric effect. Number one, the following four important features are obtained from photoelectric effect. When the light is shown on the metal, photoelectron is immediately emitted, means instantly the electron will come out. And for each metal, there exists a minimum frequency, like at a certain frequency for different metal at certain frequency or the certain energy, this electrons are coming out or electrons are coming out. So the minimum frequency which we need to remove the electron, we call that as threshold, or minimum frequency which we need to remove electron out, we call that as threshold frequency. And only light whose frequency is higher than the threshold is causing a photoelectric effect. And what we observe the maximum kinetic energy is proportional to the frequency. Like if we increase the frequency, the kinetic energy will also increase. So the maximum kinetic energy is proportional to frequency of incident light, and the photoelectron current increases when we increase the intensity of a light. Like if more light intensity or high light intensity, more light on a unit area every second, there will be more electrons will come out or greater photo current. So now the debate that whether the light is acting, because light, as we discussed wave particle duality in the last session, that we discussed that the particle can behave like a wave and wave can behave like a particle, and that is called wave particle duality. So now the question arises here, what is the nature of the light? Whether the light is acting like a wave here or light is acting like a particle. So if light is acting like a wave, light is electromagnetic wave. But if light is acting like a particle, the particle of a light is called a photon. And how we show? Like an oval, inside there's a wave, so that particle is called photon. So this photoelectric effect, when we try to explain the using a wave nature, like we say that light is having a wave nature, we are not able to explain this photoelectric effect for a wave nature. We are able to explain with a particle nature that when light is having a particle nature, this photoelectric effect can take place, but not because of wave nature. So photoelectric effect give an idea that light is having a particle nature. There are different effects which support the nature of the light, like interference, Doppler effect. These are the effects which shows, or interference, Doppler effect, diffraction. These are the the effects of the light which shows that light is having a wave nature. But photoelectric effect, especially this photoelectric effect, it gives an idea that light is having a wave, the particle nature, wave nature cannot explain the photoelectric effect. And due to this, we say light is having a dual nature. Dual nature means sometimes light is acting like a particle, sometimes light is acting like a wave. So in photoelectric effect, so it depends on which effect we are studying or which effect we are discussing. According to that effect, the light shows its behavior. So if we are discussing, so light can have a wave nature, light can have particle nature. So if we try to explain reflection, So when we try to explain the reflection, the wave nature can support that light can undergo reflection. Particle nature also can explain that light can undergo reflection. Refraction means change in speed when the particle travel from one medium to another. So refraction can happen for wave. Refraction means change in speed traveling from one medium to another. It can also happen for particle. So wave nature or particle nature both can explain the reflection and refraction. But what about diffraction? Diffraction is totally a property of a wave. It is not a particle property. That's why electron diffraction suggests that electron is acting like a wave. Interference or superposition. Interference is totally a property of a wave. Particle can collide. For particle, collision can happen, but particles interference cannot happen. Like it's not like particles interfere and give rise to another particle. So, and the Doppler effect, that is a relative change in frequency or wavelength when the object are moving. So Doppler effect also shows that light is having a wave nature. But which effect shows light is having a particle nature? That is photoelectric. And the spectrum, the line spectrum, that we'll discuss later in this chapter. So these are the things like phenomena. Some of the phenomena can be explained by wave nature, some of the phenomena can be explained by particle nature. That is why what we say about light, we always say light is having a dual nature. Dual nature means sometime it is acting like a wave, sometime it is acting like a particle. So it can act like both, but not at the same time. Either it is acting like a wave or it is acting like a particle. So we call that as photoelectric. We call that as dual nature of the light. So photoelectric effect cannot be explained by the wave nature. Only particle nature can explain this photoelectric effect. So what is the reason for that? Like inconsistence of the experiment result with a wave theory. Like wave theory does not support the photoelectric effect. So what are the reasons why the wave theory is not able to support or explain this photoelectric effect? So according to wave theory, wave is continuous and the electron can continuously absorb energy from the light until they get out. But what we see here in a photoelectric effect, what we see that these electrons, the moment the light falls, so according to wave theory, the electron, like there is a wave coming continuously, so electron will absorb energy until it get enough energy and it will go out. So it will take time. According to the wave theory, electron should take time to come out because it is taking energy from the wave, and after absorbing energy from the wave, once it get enough energy, it will go out. But this is not what happened. What we observe the moment the light falls, if the energy of the light, the energy of the incident light is more than the work function, then instantly electron will come out. So it's like immediately when the light falls, electron come out. But according to wave theory, this should not happen. According to wave theory, the light electron should absorb light for some time. Once it has sufficient amount of energy, it should go out. So practically, this is what happened. And according to theory, according to wave theory, this should happen. But because this is not happening, so it means it is contradicting with the wave theory. So it means the light is not having a wave nature when we explain the photoelectric effect. Is it clear? The first point of contradiction or inconsistence to the experimental result. Then what about the second point? So according to first point, Electron should not come out immediately. Like according to wave theory, electron should take time. And according to wave theory, the energy is measured by intensity and it is not related to frequency at all. Like when we say if we increase the energy or if we increase the intensity, the energy increases. But in terms of particle, the intensity is not related to energy. It is related how many photons are coming on unit area. Like if we have a metal and first one we consider electron, the light is having a wave nature and that falls on the metal. When it will falls on the metal, the electron should absorb energy. Any light, like example, there should be no work function. If light is having a wave nature, so if light is having a wave nature, there should be no work function. Means any energy can remove the electron out because a wave continuously energy is coming, electron absorb energy, and when it absorb energy, it will go out after some time. This is according to wave nature. But this does not happen. According to wave nature, it say there should be no work function, like no minimum possible energy should be there. Any energy can remove the electron. There should be no threshold frequency. And electron should take time to come out. That is according to the wave nature. But this does not happen. There is a work function, minimum possible energy which electron need to come out. Not all of the energy can be remove the electron out. So if we say the work function for, and every metal is having its own work function, and the light is coming in the form of particle which we call photon. So this photon, if the energy of the photon, this is according to particle nature. So according to particle nature, when the light, the energy of the photon, say this energy of the photon is example 20 joules. So according to particle nature, electron absorb one photon, and if the energy of the photon is equal to or more than the work function, the electron immediately will come out. If energy of the photon is less than the work function, then electron will not come out. So if example the work function is 30 joule and energy of a photon is 20, will this electron will come out? Yes or no? If the energy of the photon is 20 and energy work function is 30, so the electron will not come out. So one electron, according to particle nature, one electron absorb one photon at the time. It cannot absorb two photons. So even two photons were there and each of energy 20 joule. Will this electron will come out? Yes or no? Each photon is having energy of 20 joule. So what will happen? Again, the answer will be no. Why no? Because one electron absorbed one photon at the time. One electron cannot absorb two photons. So if energy of the photon is less than the work function, there will be no photoelectric effect. Then if the energy of the electron is more than or equal to the work function, then this electron will go out. Like example, if this is 40 joules, 30 joule is used to come out and remaining 10 joule as a kinetic energy. So according to particle nature, there should be a work function, there should be a minimum possible energy to remove electron that we found. There should be a threshold frequency and within an instant the electron should come out. So this is what happened. So wave theory does not support or explain photoelectric effect, the particle theory can explain photoelectric effect. Is it clear at this point? Then what will be the effect if we increase the intensity? So if we increase the intensity of the incident light according to wave nature, what should happen, and according to particle nature? So according to wave nature, when we increase the intensity, so increasing the intensity will increase the number of the electrons so if the light is having a particle nature, if we increase the intensity, it means we will increase the number of electrons coming out from the metal, or we can also say the current will also increase, but the kinetic energy will remain same. There should be no change in kinetic energy. But according to the wave nature, like light is, if the light is having a wave nature to explain the photoelectric effect, then what should happen if we increase the uh, according to wave nature, if we increase the intensity, it should increase the kinetic energy, because intensity means how much energy is coming on unit area every second. So increasing the intensity means like more energy will be there according to wave nature. So increasing the kinetic, it should increase the kinetic energy, but the number of the electrons should be same according to wave nature. And according to particle, if we increase the intensity, but what is the meaning of increasing the intensity in terms of particle nature? Look, if we have a metal surface and I say I change the intensity in terms of particle intensity, and this is the same metal, so the work function of this metal is example 30 joules, and increasing intensity means more photons are there, like first example 2 photons are coming and each photon is having a 40 joules of energy. Then we have more increasing intensity in particle nature means more photons will be there, but the energy of the photon is not changing. According to particle nature, increasing intensity means like more photons are coming. So if 2 photons are coming towards the metal, each electron absorbs the photon. So how many electrons will come out? If 2 photons are absorbed and they have the energy more than the work function, so how many electrons will come out? There will be 2 electrons will come out. And what will be the kinetic energy of the each electron? Because the work function is 30, 40 joule is there, so remaining 10 joule will be the kinetic. So 10 joule of kinetic energy for electron 1 and 10 joule of kinetic energy for electron 2. And if it is having, like if we increase the intensity, more photons are coming towards the metal, so more photons are there, more electrons, more greater number of electrons will absorb. So this will emit out more electrons out from the metal. But the kinetic energy, because one electron absorbs one photon, that's why the kinetic energy of the electrons will be same. So you can clearly see that when we have a low intensity, this is when we have a low intensity. Low intensity means few photons, and high intensity means more photons. So increasing a number of photon, the light particle increasing the number of electron, but the kinetic energy will remain same. But what about the wave? According to wave nature, what should happen? So this is what is happening. So particle nature supports, like according to particle nature, this should happen and this is happening. That increasing the intensity will increase the number of electron, but their kinetic energy remain same. But what about in terms of wave? If we increase the intensity, it means how much energy is coming on unit area in 1 second. That's called intensity. So this is a region where the light falls. So increasing intensity means what? Means each in a light wave is carrying more energy. Like here 30 joule. According to wave nature, increasing the intensity means increasing the energy of the light, but the number of electrons on a unit area will remain same. So what will happen? Because if 30 joule, according to wave nature, if there's energy of 30 joule on a unit area, so two electrons will come out, number of electron, and here 40 joule on unit area, so two electrons will come out. But because this is having less energy, so these electrons will move slower, and this is having high energy, so electrons will move faster. So according to wave nature, if we increase the intensity or energy on unit area, according to wave nature, intensity changes when we change the energy on unit area. And what will be the effect? The number, according to wave nature, the number of electrons should be same, and it increases the kinetic energy. But this is not, we don't observe this. This does not happen. What happen is when we increase the intensity, according to light nature, there will be more photons. So more photons means more electrons will come out. And as the number of the electron increases, what will happen? The number of the electrons increases, so the current or the photocurrent will also increase. But the speed at which these electrons are moving won't change. So particle wave nature is not able to explain this. Particle nature is able to explain the photoelectric effect. Is it clear that how increasing the intensity changes the. And the last point, when we increase the energy, so when we increase the energy of a photon, what we observe in a photoelectric effect, the kinetic energy will increase, but the number of the electron will remain same. So this is what happened. The particle nature explained this, but the wave nature is not able to. So we have a metal which is having a lattice of a positive ion and the delocalized electrons. And when these electrons are emitted out, we assume that these electrons are always emitted out from the surface, because electrons which are inside the metal structure, they need more energy. But work function is for electrons which are exactly at the surface. Like it's like an evaporation in which the most energetic molecules escape. So same thing happen in photoelectric effect. The most energetic or at the surface will escape. Now, when we increase the energy of the light, so in terms of particle nature, increasing energy means increasing the energy of the photon. So example, two photons here, two photons here. Because it's the same material, so work function is same, say 30 joules, and work function is also 30 joule. So when the light fall, like increasing the energy means like photons will have more energy. So here we have say 40 joules and 40 joules, and we other one we have 70 and 70. Because there are two photons, so how many electrons will be emitted? If two photons are there, only two electrons will come out, because one electron absorbs one photon at a time. So two electrons will come out, but the speed at which these electrons will come out, that will be different. If the energy of the incident is 40, then the speed at which this electron will come out, that is 30 and 30. Because the work function is 30, so that will be 10 and 10. So each will have 10 joule, and when 70 and 70, so each will have 40 joules of kinetic. So increasing the energy of the photon, or increasing the energy, will increase the speed at which the electrons are coming out, but not the number of electrons. So this again explained by particle nature. Wave nature is not able to explain this at all. So that's why we say when the light in a photoelectric effect can only be explained by a particle nature, the light cannot have a wave nature, we cannot explain this photoelectric effect. Is it clear the concept of the photoelectric effect, that when this is when the light falls on the certain metal, the light with a certain frequency remove the electron out from the metal, and we call that as photoelectric effect. Any doubt till this point?